We're given a fourth degree polynomial. We want to know what's the derivative of its inverse evaluated at 17. In other words, f inverse prime of 17. We're also given the fact that f inverse of 17 equals 2. So there's sort of two approaches here. One is the very hard way, and one is the easy way using the formula. The hard way would be to take the inverse function, derive that, and then plug in 17. Now, if you look at that original function, x to the fourth power, and then minus x plus 3, this would be very challenging to find the inverse. However, we have that formula. That formula goes like this, that f inverse prime of a, this is equal to 1 over the original function's derivative evaluated at f inverse of a. Here, that a value is 17. We're looking for what's f inverse prime of 17, and we were given the f inverse of a right there. We know that it's 2, so all we have to find is 1 over f regular prime of 2, because f inverse of a, f inverse of 17 is 2, it goes right in the denominator. So thanks to this formula, our challenging problem came down to just finding a regular derivative and plugging it in. Let's take the derivative of this function. We just have to use a couple power rules. The derivative of x to the fourth, that's 4x cubed. The derivative of minus x, that's minus 1. The derivative of 3 is 0 since it's a constant. Now let's just plug in f prime of 2 here, since that's what we're looking for. Remember, we have an f prime of 2 in the denominator. Let's just plug in 2 for x. 4 times 2 cubes minus 1. 4 times 2 cubed. 2 cubed is 8 minus 1. I believe that's 32 minus 1, or 31. That's what goes in the denominator here. Our answer is 1 over 31. That's the derivative of our inverse function at 17. We used that formula.